circuit analysis, DC circuit analysis. In this video, so we are going to discuss how to find the unknown current in the given circuit. There are many methods are available. So here we are going to discuss mesh analysis. So mesh current analysis method for DC and AC circuits. Using these mesh analysis, we can find out the unknown current in the given circuit. So by applying a KVL, we can find the unknown current. And these mesh analysis is applicable to a planar circuits. And steps are a procedure to find the unknown current using mesh analysis is step 1. So we have to find out the number of mesh in the given circuit. For finding out the number of mesh, the formula is B minus N plus 1. B minus N plus 1. What is a B? B means B represents a branch. Okay, so B represents a branch. B represents a branch. N represents the number of node plus 1. So B represents the branch. N represents the node plus 1. So number of mesh can be calculated by the formula B minus N plus 1, where B represents the branch, N represents the number of node plus 1. So for step 1, so we have to find out the number of mesh. Second, assign mesh current equivalent to number of mesh. Then applying a KVL to each N mesh. So form the express the voltage equation in terms of mesh current. Then solve the resultant equations to get mesh current. So there are three steps. One is finding out the mesh current, assign the finding out the number of mesh, and assigning the mesh current by applying a KVL, right? Express the voltage in terms of mesh current and solve the resultant equation to get the mesh current. So these are the three steps or procedure for calculating the unknown current. Now we will discuss the problem how to calculate the mesh current from the given circuits. So the figure circuit diagram, there are three loops: loop 1, loop 2, and loop 3. Right? This is loop 1. Current flowing in the loop 1 is I1. For loop 2, I2 current is flowing. For loop 3, I3 current is flowing, and the current direction they given in these circuits. The given we can use. Otherwise, we have to draw the current in the corresponding loops based upon the voltage source given. Step 1, we have to write the mesh matrix equation, right? That is V equal to I into R. This is V, I, and this is R. Okay, and this equation, this matrix formation depends upon the number of meshes or loops. So in this diagram we have three loops, right? So three loops. So we have to use 3 by 3 matrix. Okay. So we have to write as here in this diagram we have three meshes. So R11, R12, R13, R21, R22, R23, R31, R32, and R33. Right? The resistance between loop 1, resistance in the loop 1, and the resistor between common to loop 1 and 2. The resistor is common between loop 1 and 3. So here the resistance is common between 2 and 1. The resistor is common between all the resistor in 2, loop 2, and this is between 2 and 3. Like this, we have to write all those resistance value, and here we have a 3 current value and the voltage source value. So the first one, find the resistance matrix. R11 means total number of resistance in the loop 1. Right? So if you see the figure, so this is loop 1, right? So total number of resistance present in the loop 1. So 4 plus 8 plus 4. So 4 plus 4, 8, 8 plus 8, 16. So total number of resistance in the loop 1 is, that is R11 is total number of 3 resistance. Total of 3 resistance. And R12 means, what is the meaning of R12 means? The resistance common between 1 and 2. The resistance common between 1 and 2. Okay, the resistance is common between 1 and 2. What is the value or common value between 1 and 2? This is 4, right? So this is loop 1 and loop 2, right? Between two loops, the common resistance is 4. Like that, between 2 and 3, okay, what is the common resistance? 1. R23 is 1. If for R31, between 3 and 1 there is no value, so we can make it as a 0. So like this we have to write the equation. So here we mention R11 is total number of resistance, R22 total number of resistance is loop 2, R33 is total number of resistance in R3. Okay. This is R12 or R21, loop 1 and 2 common resistance value. R13 means loop 1 and 3 there is no value or resistance, so 0. R2 3 or 3 2 value is 1. And voltage sources, so we have two voltage source in so in the loop 1, so 10 minus 5, the loop 2 5 minus 8, the loop 3 20 minus 8. Okay. So we calculated, so 10 minus 5, 5 minus 8, 20 minus 8. The next one is, so we have to substitute all those value in the matrix equation, and then we have to find out the determinant. So del value, so this is your del value, this is determinant del value, right? So for finding out the del value, we can get a value, answer is 1328, and del 1 means, so the first, right, first 16 minus 4 is replaced with the this source value, voltage source value, 5 minus 3 and 12. Again we have to calculate the value. Okay. Next one, so we have to calculate similarly del 2 and del 3. So the del 2, second portion is replaced by our voltage source. For del 3, third portion is replaced by our voltage source value, right? Then we have to calculate our del 2 and del 3. For I1 value, formula is del 1 by del, determinant del 2 by del, for I2 and I3 del 3 by del. So thereby we can calculate I1, I2, I3, that is current flowing in the loop 1, loop 2 and loop 3, that is mesh current. So this is the method of procedure for calculating the mesh current in the given circuit.